Okay, problem 37 is asking us to find our derivative here, dy dx, of arcsine of e to the x. And I wonder if part of the question about this one right here is what that goofy notation of arcsine mean. Just needs to remind everybody here that arcsine is just a different way of writing what we are more familiar with here as the inverse sine of e to the x. I'm not certain this is the reason it came about, but back in the 1950s, when they were typing math books, it was difficult for them to put that kind of subscript there, and arcsine is a way for them to do it just with a typewriter, of just typing in letters there. So regardless, that's what we're trying to work on. This is really an inverse sine derivative. So let's get to it then, guys. Let me switch to blue and let's go get them. So the derivative of y with respect to x equals, and I'm going to focus on what we're doing right here. We're taking the inverse sine of some ratio right there. So that derivative is going to be a fraction. And we would normally have a 1 on the top, but I'll leave that out for just now. All over, it'd be 1 over the square root of 1 minus u squared. So it's going to be 1 minus, and then it's going to be this ratio right here, e to the x squared. And just real quick off to the side, guys, when you take e to the x and square it, power of a power is when you multiply your exponents together. So this is going to become an e to the 2x power. So that takes care of the square root of 1 minus u squared down on the bottom, but now times the derivative within, or in this case, the derivative of this ratio. And the derivative of e to the x is just e to the x. And that's why I didn't bother putting the 1 in the numerator here, because I saw that the chain rule was going to give me a derivative to put there instead. The 1 there certainly wouldn't be wrong if I had it right there, but it's certainly not necessary either. So, that's what we've come up with right here, and I don't know, in looking at that right there, guys, if there's something that we could do to simplify that answer. I'm actually pretty content with where that is right now all by itself. So I'm going to take a look real quick at the solutions manual here, if you guys can bear with me stalling for just a second right here, and I want to see what they came up with for their answer here for that problem. So let's see, 3.8 number 37. All right, I was looking at that denominator right there to see if there's anything that we could do to factor out, and nothing jumped out at me here. So where'd we go? Overshot it. Here we go. Yeah, they left it exactly the way that's written there, guys. All right, so that is our final answer there for problem 37.